So to summarize conceptual design, it follows requirements analysis and yields a high-level description of the data to be stored, typically in an ER diagram. ER modeling is popular for conceptual design. It's pretty expressive. It's actually pretty close to the way we think about our applications in terms of entities and relationships. And there are, as I said, a number of minor variations on the ER model, both in terms of how they're drawn. We saw crow's foot notation as well as our own notation. And also conceptually, there's extensions to the ER model and subtleties in them. And so you may find when you go out in the world that what you learned in this class isn't exactly what you're using in the field. Hopefully the concepts here, though, are enough of an introduction to make it easy for you to switch over. There are some additional constructs even in traditional ER modeling. We've seen weak entities, but there are other things we haven't seen, like ISA hierarchies, that you might want to read about if you're curious. Some of that's covered in the text. And then we looked at some integrity constraints. Particularly, we looked at key constraints, which are represented by arrows, and participation constraints, which are represented by bold lines. Some foreign key constraints are also implicit in the definition of a relationship set, as we saw when we mapped things down to the relational tables. But there are other constraints that you may want in your data, notably what we're going to learn called functional dependencies, that can't be expressed in the ER model. And so to do some more fancy constraints, we're going to need to get down a level into the logical model of relations in order to capture those constraints. Constraints are important because they help you capture not only what's possible in the real world so that you can write it down, but also what's not possible in the real world, things you should not be able to write down, or things that you shouldn't accidentally be able to enter into the database. Constraints help you keep that database clean and correct as much as possible, so they're worth thinking about. I will say that ER design is subjective. There's many ways to model a given scenario. Sometimes they're equivalent and just look different, but many times they are subtly different in their semantics. And it often depends on how you view the thing you're modeling. So what's your opinion about what's a correct state of the world? And also what you're going to do with this database in terms of querying it, updating it, and so on in the future. So what parts of the world are you actually trying to capture in the database? And these are subjective choices because our views of the world and our views of what we're going to want to use our software to do about modeling the world can be different across people and can change over time. So there's no right answers very often for ER design. It's often quite subjective. And I'd say that analyzing the alternatives, as we've seen, can be quite tricky. So we looked at some common choices: entities versus attributes, entities versus relationships, binary versus n-ary relationships, whether or not to use aggregation. These are all subtleties that help try to capture what it is about the real world you're trying to write down. And the trade-offs here often are about different interpretations of the world and how we can capture them correctly. For good database design, as we said, the relational schema that's going to come out of this ER diagram needs to be analyzed and refined further. And so what we're going to learn about next is what's called functional dependencies and normalization. And that'll help us refine relational databases and get further semantic correctness out of our models.